6.5 Part 4 talks about the properties of the dot matrix. So it tells us if u, v, and w are vectors and c is a scalar, then u dot v is equal to v dot u. So again, it's going to be commutative, just like we looked at with vectors the other day. If we have part number 2 tells us if we have u times v plus w, then that's equal to u dot v plus u dot w, which means you can distribute it. If you have 0 dot v, for number 3 here, that's equal to 0, so your 0 property exists. You have v dot v, that's the same thing as the magnitude of v squared. And if you have c times u in parentheses dot v, that's the same thing as saying c times u dot v in parentheses, which is the same thing as saying u dot c times v in parentheses. So it's associative as well. So let's look at example 1 here. It says let v and w be two vectors in the planes of magnitudes 12 and 7 respectively. The angle between v and w is 65 degrees. Find the magnitude of v plus 2w to the nearest tenth. Now it gives us a hint here. It says use the property of vectors to expand the magnitude of v plus 2w squared, then substitute magnitudes of v and w into the expression. Alright, so let's just kind of talk about what we've been given and what we're after and how are we going to solve it. So what do we know first? What was given? Well, they told us the magnitude of vector v is 12, and they told us the magnitude of vector w is 7, and they told us our angle is 65 degrees. And what do we want? Well, we want to find v plus 2w, the magnitude of it, right? Alright, so how are we going to do that? Well, if you look at your properties above, only one of them had something with a magnitude in it. But it had it squared. And that's what they gave us here, okay? So we're going to take this to help us here at the beginning. And we'll remember, what does it mean to be squared? Well, it means the vector times itself. So we're going to take v plus 2w dot v plus 2w. Alright, and so then we're just going to distribute. So we got v dot v, plus v dot 2w plus 2w dot v plus 2w dot 2w. Alright. So v dot v gives us the magnitude of vector v squared. That's one of the definitions above. Number 4. Plus, and so here, this one's just going to give us, I'm going to change the order, so it's going to be 2 dot vw. Or, I'm going to write it as 2 times v dot w. How about that one? Doesn't matter. Okay, here, notice we're going to get the same thing. W dot v is the same as v dot w. Plus here, we're going to get 4, and then I have w times w, which means it's going to be the magnitude of w squared. And then we still got like terms right here, so let's go ahead and combine them. Okay, so we're looking at this. Wait a minute. This is what we've been doing earlier in this lesson, isn't it? So I'm going to change that over. So I've still got my magnitude of v squared plus 4. But remember, v dot w is the same thing as saying the magnitude of v times the magnitude of w times cosine of theta. And then I got my plus 4 magnitude of w squared. And remember, this is all equal to the magnitude of v plus 2w squared. Okay, just brought that down. Alright, so let's plug in what we know here. So we know the magnitude of V is 12 squared plus 4. The magnitude of V is 12. The magnitude of W is 7. Cosine of theta is 65 degrees. Look over in your given section there. That's why I went ahead and wrote it out. Plus 4 times the magnitude of W is 7 squared. So I'm going to simplify this a little bit, but if you're good with your calculator, you could just type it all in. So this is what, 144 plus 4 times 12 is 48 times 7, which is 336. Cosine of 65 degrees plus 4 times 7 squared, that's 4 times 49, which is 196. Okay, and we could still combine some like terms if you want to, but let's go ahead and just plug that part into our calculator. And so we have the magnitude of V plus 2W squared is approximately 481 point, and I'm going to take this out several places because this isn't my final answer, so I don't want to round to the nearest tenth or anything yet, okay? Alright, but what were we after? Well, remember, we wanted the magnitude of V plus 2W, so how do we get rid of that square? Well, just like we normally do in algebra, we take the square root. So that gives us the magnitude of V plus 2W is approximately, and when I put this in my calculator, I just want to prove a point here. I got 21.954. But it says to go ahead and approximate that to 1 decimal place, or to the nearest tenth. So that would be 20. That's going to become, that 9 becomes a 10, so it's going to become 22.0. And so there is our solution.